Hello everyone, welcome to the Cloud Solution Architect course. I am Kumar and I have 8 years of solution architect experience. In this course, I will start from the very basic and cover different topics essential for solution design. We will also do some practicals in AWS Cloud, but the learnings will be applicable to any cloud you work on. This course will help aspiring solution architects and designers learn the basics as well as prepare for interviews and certification exams. So before we start, we need to answer the basic question. Why do we require solution architecture? Let's understand what solution architecture is and why is it essential. Solution architecture is the blueprint or a roadmap or a high-level design of how a specific software solution will be designed, built, and integrated into a business. It's like being the bridge between business needs and technical implementations. To understand this definition better, let's look at an example. And as we do that, please keep the keywords high-level design or a blueprint and the bridge between business needs and the technical implementations in mind. Let us say, due to a business process upgrade during the COVID period, a bank wants to provide its customers the capability to e-sign account opening forms that were hand signed earlier. Now, this is a business requirement. A solution architect has to take this business requirement and design an e-sign capability that can allow the customers to digitally sign documents. The architect has to choose the solution in such a manner that the business goals are reached at optimum cost and the customers get a smooth and efficient experience. Also, the solution should be secure and trustworthy. The technology to be used for such a system has to be detailed by the architect.
Now let us take a deep dive into the responsibilities of a solution architect. The reason for this deep dive is that in any solution architect certification exam, there will be questions related to the responsibilities of a solution architect. So, if you are able to categorize the responsibilities and prepare accordingly, you will be better placed to succeed. Similarly, when you go for a job interview, they will either ask you direct questions related to these responsibilities or give you use cases related to them. The first responsibility of a solution architect is to provide the end-to-end technical design of the application. As part of this, the different components as well as their interaction patterns has to be detailed by the architect. The architect also has to choose the right tech stack, the frameworks and the platforms on which to implement these. I will explain these activities in detail next. Now, depending upon the need, the architect might choose a 2-tier or a 3-tier architecture and select the components accordingly. Let's take an example of a 3-tier architecture. As we see on the screen, a 3-tier application will have a front-end or presentation tier, a back-end or logic tier, and the database tier. The architect defines each tier and selects the technology for them. For example, there can be a front end with a mobile application or a website. The architect can choose different technologies for each one of them. For example, for the website, either AngularJS or React.js can be chosen. Similarly, for the backend, there can be multiple technologies like Node.js or Spring Boot microservices. There can be different options for database as well. The architect may choose to use an open source PostgreSQL or a licensed product like Oracle DB. Next, we come to the APIs or application programming interfaces, which defines the inputs to be passed and the outputs to be expected from a service. API design is a separate topic in itself, which we can cover in a different video. When the front end communicates with the back end, it uses these APIs to get the job done. The architect also defines the database schemas. The technical architecture should also ensure system scalability. That is, the ability to respond to added workload by increasing number of servers and other resources. Similarly, good performance and security has to be ensured by the architecture. Performance refers to the latency or waiting time the user experiences when it uses the system. Security ensures that the malicious actors do not get access to system data or functionality. Moving ahead, the architect has to align the solution with business needs so that the output is what is required. He also ensures that the user has a smooth journey while using the application. Be it an e-commerce system or a tax payment system, the user should be able to achieve the desired results in fewer steps. The next important consideration while architecting a system is to ensure the system can integrate with other existing systems. For example, in the e-sign application we discussed earlier, the new solution should be able to update the same system of records that the existing manual system updates. The design of data flows and APIs are also part of the integration strategy. Now, apart from these considerations, the architect has to ensure that the non-functional requirements are also met. We have already discussed scalability. Or does the system have ability to grow? Performance, or is it fast enough to meet requirements? And security, that is the data protected? Apart from these, availability refers to the ability of the system to stay up and running. Maintainability refers to the ease with which the system can be upgraded and kept in good health. Next up is risk mitigation. Under this, the architecture has to point out risks and rollback options. It can also provide workarounds if risks materialize. Architecture should also provide governance roadmaps and standards. This refers to any governance process or team that needs to be set up. For example, you might need a set of approvals before a new AD group can be created. Last but not the least is the deployment planning and roadmap. The architecture should highlight the order of deployment of components as well as the rollback order. So to conclude this video, let's see what happens if you don't have a solution architecture defined. The greatest risk is you may end up spending money on something you didn't need and not get what you want. Or you might over-engineer to spend much more than what you should have actually spent. Or else, you can also end up with a rigid system that cannot interoperate with other existing systems or future systems. In the image on the screen, we can see a tire swing built elaborately at a huge cost. It looks like a bridge and roof company ended up building a swing. This is an epitome of over-engineering. Thank you for listening. Please put your questions in the comments below. Also, let me know if you don't agree with anything I covered in this video. Thank you very much. Please join me in the next video on networking in cloud. Till then, keep learning.